Sorry to harp on this again, but when this is coming from your calculus book, which is terrific, it's written by James Stewart, and when he asks for a domain, what he really means is what's the max possible domain I can have. I can certainly restrict this somewhere where I don't have a 0 in the denominator, and that could be the domain I choose it to be. And the only reason I'm saying this is because this is actually going to come up in MA 104. Okay, for now, if I want to answer this question though, I have to first look at this from the viewpoint of what x can't be. And the denominator can't be 0. I'm not allowed to work with a denominator 0. So I find out what x can't be by setting the denominator equal to 0 and solving for x. And I get that x can't be either 5 or negative 5. But it can be anything else. Anything else is fine to plug into here. And so if I draw a little number line, I'm okay until I reach -5. I'm not allowed to have that, so I put a circle there. I'm okay between -5 and 5, and then I put a circle there, no, and then I'm okay here. And so here, if I group that together, this chunk here up till the first circle is from -infinity to -5, but not including -5. And the second chunk is between -5 and 5, but not including -5 and 5, the endpoints. And then the third chunk is 5 to 8, and I put open brackets around this. If you don't remember what these U's mean, they mean union. So it's this chunk, union this chunk, union this chunk, and I represent it in this open interval notation. Here we have something called piecewise defined functions. They're like if-then statements if you did any programming, and they can be a little confusing, but it's pretty easy when you think about it in this way. I first take this first one here, f at -7. In this case, x is -7. These are two branches, and I have to decide which branch does my x belong to. It actually belongs to the first branch because x equals -7 is less than 0. And so because that's less than 0, it tosses me up into the first branch, and that's where I belong. And my f of x in that top branch is x plus 3. So f at -7 is going to be -7 plus 3, which is -4. So that's how I get this. My eraser pen stopped working on my Apple iPad, so now I'm going to have some deletion of things. But the next thing they ask me is x equals 0. X equals 0 is in the second branch because I have a greater than or equal to 0 here. So I plug in 0 into the second branch, and I get 1. So 1 goes there. Last one, x equals 4. That's in this branch as well because 4 is bigger or equal to 0. And in this branch, f of x is 1 minus x. So 1 minus 4 is -3, and I get -3 here. Then I'm asked to graph this equation. If I want to graph this, I need to graph both pieces. So the top branch is for all x's less than 0. Choose some x values that are less than 0, but do the cut point. Notice the cut point here is not part of this branch, so I'm going to put a dotted 0 because indicating that it's at the cusp, but it's not really part of this branch. Those are easy. I plug in chug, get my x's, I get my y's, and then here in dotted lines, if I plug that in, I get 3. So from x equals -infinity to 0, if I plot those points, I do that, and where I had the dotted part, that's an open circle because it's not included. I do the same thing for the other branch. X and y is 1 minus x in this branch. The branch only starts at x equals 0 and to the right of 0. So I pick some numbers to the right of 0. This time I don't have to make dotted lines because 0 is actually included. And I make a chart, and I plot those points. Back in the old days, remember we plotted points? Here we are. And this is what my graph looks like. This is a function. I know you think of functions as vertical line test. You see that it passes a vertical line test because even if I started right here, it passes in only once. So it's a valid function. And it is a reflection of this piecewise. From here to here, it's this. From here to here, it's this.